Early galaxies were packed with a magnificent firestorm of star formation when the universe was less than 5% of its current age. After the Big Bang, the universe saw a massive burst of star creation that may have been the most active in its history, a few 100 million years later. NASA's James Webb Space Telescope, which got into orbit in late 2021, will allow scientists to see back in time to the start of the universe. In this video, I'm going to show you the incredible discoveries that it will detect. These discoveries will probably solve questions like how the space was created. Don't believe me? Then watch the video till the end and let me prove you wrong. And since you're here, also make sure to subscribe to don't miss any new mind-blowing videos about this space. And now, let's get into the video. To accomplish this large, ambitious study, JWST's Advanced Deep Extragalactic Study will need around 800 hours of observation time. With Webb's infrared sensitivity, which has wavelengths longer than visible light and is invisible to the human eye, it takes advantage of this technology. They assume that galaxies begin developing in the first billion years after the Big Bang and reach adolescence between 1 and 2 billion years later. They're working on the project's early phases. Professor Daniel Eisenstein, an astronomy professor at Harvard University and a fellow JADES member, went into further depth on this subject. Infrared telescopes are needed because light travels throughout the universe at a larger wavelength owing to its expansion. Also known as infrared radiation, this means that even while stars primarily produce visible and ultraviolet light, the Earth's magnetic field is continually moving this light out into the infrared region. Webb is the only telescope capable of seeing these earliest galaxies. The near-infrared camera, as well as near-infrared spectrograph teams of the Webb Space Telescope, collaborated to conduct the JADE survey. Near-infrared spectrograph and near-infrared camera are combined with Webb's mid-infrared instrument, which has both a camera and a spectrograph in it, in this software. Coordinated, parallel observations will ensure that all three JADE sensors are used to their full potential. NASA's Hubble Space Telescope, Chandra X-ray Research Center, and the ground-based Atacama Large Millimeter Submillimeter Array and Jansky Very Large Array Radio telescopes will be combined with Webb's results to produce an unprecedented view of the universe's very earliest galaxies, according to an announcement from the National Science Foundation. A comprehensive image of galaxies may be obtained by seeing them in all of their many wavelengths, which will enable scientists to examine the light emitted by the galaxy's stars, as well as the dust and interstellar medium and the supermassive black holes presumed to be hidden inside them. The James Webb Space Telescope, a NASA project, will provide fresh information on how galaxies evolve by allowing us to view them back in time. With Webb, we will be able to see farther back into the past than we ever have before, helping to fill in the blanks of cosmic history. The Great Observatory's Origins Deep Survey provided the crew with two well-studied domains. An effort called Great Observatory's Origins Deep Survey brought together observations from NASA's Spitzer and Hubble telescopes, as well as the European Space Agency, Herschel and XMM Newton telescopes, and the most powerful ground-based observatories to study the faintest light in the universe. GOODS North and GOODS South, two enormous fields in the directions Ursa Major and Fornax, respectively, were surveyed in the study. Hubble Ultra Deep Field, the deepest and most sensitive picture of the sky ever acquired by Hubble, may be found in GOODS South. Webb is going to go much more into the same subjects. They choose the field since they had so much information to support them. The fact that they've been researched at several different wavelengths made them the obvious choice. That's the sentiment expressed by Marcia Ricci, who co-directs the JADES team with Pierre Ferraud of the European Space Agency. Ricci is also a professor of astronomy at the University of Arizona and the main investigator on Webb's near-infrared camera. The researchers are also keeping a close eye on the two widely separated fields to compare the variations in the number of galaxies at various distances inside one field with that of the other field. Observing the evolution of galaxies, black holes, and stars. Astronomers still don't know how fast galaxies develop and assemble, and how quickly and where they create their stars. Understanding the distribution of stellar mass in young galaxies, as well as stellar brightness, star formation rates, and stellar age, size, and composition, are some of the more ambitious aims of the JADE's research. This mission will look at the nuclear activity of galaxies, figure out how they're structured, and map out gas flow across a vast area. Understanding the features of the initial generation of black holes is also an objective for the program. For the time being, they can only go on theories and conjecture as to why there is such a strong correlation between a galaxy's core black hole and its bulge mass. The JADES team aims to shed light on this relationship's underlying dynamics. Moreover, 1 billion years after the Big Bang, which is less than 10% of the age of the universe now, scientists discovered these supermassive black holes. However, it is difficult to comprehend how such massive black holes could have formed so early in the history of the universe. As part of ESA's near-infrared spectrograph, instrument science team and a professor of experimental astrophysics at the University of Cambridge in the United Kingdom, Roberto Maulino, a JADES teammate, explained that they hope to detect the primeval seeds of these monster black holes, the smaller black holes that formed soon after the Big Bang, and to understand what were their masses and how they were accumulating mass and where they were located. To comprehend the mechanisms that led to the creation of these creatures, Webb will be the sole facility available for a long time. In search of the first stars. Another question surrounds the gas that exists between galaxies, which astronomers now understand to be highly ionized and transparent due to advances in technology. However, for the first million years, it was not ionized. Instead, it was a neutral gas that was impassable. Scientists have been attempting to figure out how the change from neutral to ionized gas, and hence from opaque to transparency, took place for a long time. It is a fundamental phase change like the universe, according to Andrew Bunker, a member of the ESA Near-Infrared Spectrograph Instrument Science team and a professor of astrophysics at the University of Oxford in the United Kingdom, who is also a JADES teammate and member of the ESA Near-Infrared Spectrograph Instrument Science team. Their investigation is focused on identifying the source of the problem. It's possible that the light is coming from extremely early galaxies, and the initial burst of star creation is responsible. A major goal of the JADES mission is to identify the first population of very massive, bright, and hot stars to develop after the Big Bang. According to Bunker, finding the so-called population 3 stars, which are believed to have arisen from the hydrogen and helium of the Big Bang, is akin to finding one of the Holy Grails. For many decades, many have attempted to do so, with outcomes that have been inconclusive so far. Why Webb? Because its light is altered beyond optical wavelengths. The JADES team's targets at vast distances seem tiny and dull to the naked eye. The infrared capabilities of a huge cold telescope are the only way to see these astronomical objects. This was one of the main scientific instances that influenced the design of Webb. Astronomers might expect equivalent spatial resolution in the infrared, given Webb's size compared to Hubble's. Their vision of the universe at long wavelengths will be significantly improved because of Webb. It is also essential to the JADES program that Webb be able to simultaneously get infrared spectra from several objects. Near-infrared spectrograph will be able to take spectra of each of the more than 100 galaxies it can see at the same time. As a result of Webb's increased collecting area, ability to see fainter galaxies, and ability to concurrently examine many objects, astronomers are now able to conduct large-scale surveys like JADES that were previously unattainable. Projects like these are usually framed by theories and models that we currently have, according to Riki. Webb may uncover something previously unrecognized, a fresh surprise, and that would be fantastic. The James Webb Space Telescope launched in 2021, surpassing the Hubble Space Telescope in power. As part of his mission, Webb will investigate mysteries in our solar system, go beyond it to distant planets orbiting other stars, and investigate the strange structures, origins, and structures of our universe and our position in it. In collaboration with its partners, the European Space Agency and the Canadian Space Agency, NASA, is leading an international effort known as Webb. That's all for today's video. Make sure to subscribe to don't miss any new videos.